All right, so 1 minute to get started. I'm just setting up the live stream. Here we go. All right. Hello, good morning, everybody. I hope you're doing well. Couple quick announcements. So today we're going to be covering 1.10, which is periodic functions, and it's the last section that we cover from chapter 1. And so our chapter 1 quiz is going to be on Friday. So it'll open just right after midnight on Friday, so 12:01 a.m., and it'll be open until 11:59 p.m. And you'll need to find a 1-hour band to take that chapter quiz, and you will need to start by 10:59 p.m. in order to get the full 1 hour. So it's 10 questions, multiple choice, similar to the mini quizzes, all based on the chapter 1 material. The best way to prepare is probably to go through the mini quizzes and see what you got wrong. It is open notes, so make sure your notes are organized. So you're allowed to use any handwritten notes and a calculator. And then other than that, it's pretty similar to the mini quizzes. So if you have any questions that are on mini quizzes or homework that you're still not sure about, make sure that you stop by Drop and Help sometime this week just to get those clarified before Friday. So the upcoming reviews for Thursday and Monday are going to be on sine and cosine. So if it's been a while since you've reviewed sine and cosine, that might be a good review for you to attend. The links will be posted in Moodle. And again, after the review is over, the recording will be posted under the Getting Started heading. So if you are not able to attend but would like to review that, that's where you'll be able to find that review and past reviews. Okay, so that's it for announcements. So let's get started. I'm gonna go over to the screen share. Hold on 1 second. Okay, so today we're going to be talking about periodic functions. And so we're going to start with just sort of the most general description of periodic functions. And then what we'll do is we'll think about how we're going to be using periodic functions in this class and which ones are sort of most applicable to what we'll be doing. So a periodic function is any function that repeats its values on regular intervals. And those intervals that repeat are called periods. So 1 period is how long it takes to repeat. And so there's a whole lot of different things that happen. So like weather cycles, the moon going around the earth, like these are things that are pretty periodic that when you plot their position, you see that it's repeating, right? And the value of periodic functions is that if we can tell that something is repeating, that allows us to predict what will happen at a later time, right? And there's a lot of power in predictability, right? So people try to do this sometimes with like the stock market. If they see a trend or a pattern, they think, oh, this looks kind of periodic. I think that, this is going to happen. It's either going to drop or go up. The stock market is not a good place to test this out on, right? So keep that in mind. So we're going to start by just looking at a couple of pictures of periodic functions just to get a visual representation of what we're talking about here. And then we're going to learn some of the mathematical components that we're interested in terms of these periodic functions. So we're going to start with this first one here. They kind of look like mountains, right? But what you notice is that the pattern is repeating. So I've sort of darkened one section of this, which is part of the pattern that we can see is repeated, right? So if we start here, that's the same as if we had started here, right? So it does the same thing again. And if I were to ask you to continue this picture, you would have a good sense of what you expect to happen next, right? Because it's repeating over time. So this function's periodic. You can see the second one, similarly, we have like big bump, small bump, big bump, small bump, big bump, and then we would predict a small bump here, right? So this is repeating as we move from left to right. Some of them are a little more, I think, obvious than others. I think the first two, it's a little bit easier to see that they're repeating because of the clear sort of peaks and like the way it's shaped. But sometimes you are plotting data and you get something that's kind of like like a little more chaotic. And you kind of have to really look at it to say, oh yeah, I see something that is repeating over time. So this comes from a synergy function that has to do with our planetary rotations, where time is in years. So we're looking at how things are changing over time. And if you look closely, you start to see that there is a pattern. So you can see that there's like the double hill up here. There's the double hill up here, the double hill up here, right? And then after the double hill, we have this like slow decline. And you kind of see it happens every time after the double hill. So again, if you look and you look really carefully, you start to see, okay, there's a pattern. So if we sort of divide this up, we can see that it's the same in each of these blocks because it's repeating. Now, some people can pick up these patterns visually very quickly, and for other people, they really have to look at it for a while. And that's totally fine. So if you are looking at something and you're like, oh, I'm not really sure, you can ask somebody else to look, and sometimes you just have to look a little bit longer. So in this class, most of the stuff we're going to be looking at will not be super chaotic just because we are looking at specific types of functions. But if you're a life scientist and you're doing data at some point during your time here or in your career, that's when you might really need to visualize and look for patterns. Okay, so those are the examples of some periodic functions, just of what they look like. Now, mathematically, what are some of the things we are interested in? Okay, so one of the primary things that we're interested in is what's called the amplitude. Okay, and it's kind of a funny measure. It's not something we really have measured anywhere else. And so what the amplitude is it tells us how far we are going to vary from the midline of a function to reach the extrema. So what does that mean? If we were to draw a line that cut it in half, right, vertically, the amplitude would say, how far do I have to go either up or down to reach a maximum or minimum? Okay, and this is helpful for us because finding extrema, maximums and minimums, is something that's really valuable in a lot of ways. So how do we do this? Well, the general formula to find the amplitude is that we are going to find the maximum y value. So we're going to go up and say, what's the biggest y value? Minus the minimum y value divided by 2. Okay, so if we can identify the maximum and minimum value, we can throw it into this formula and find the amplitude. Okay, the other thing that we are interested in is called the period, which I mentioned before. And the period is the amount of time or the distance in terms of the independent variable that it takes the function to complete one cycle. So how long does it take for the function to repeat? That is sort of the question. How often do we restart this pattern that we're seeing? Okay, so these are the two sort of key things that we are interested in when it comes to periodic functions. And the reason, again, for the period is because of predictability. If we know how often it repeats, we can then make predictions for further out for information we don't yet have. Okay, so let's do one together, and then I'll have you try some of these. So let's approximate the amplitude and period on the graph below. So this is the first picture we looked at. Okay, if we wanted to look for the amplitude, what we need to do is figure out what is the maximum y value and what is the minimum y value. So if you look at these peaks here, it looks like they're right about at 3. So I'm going to say that y max equals 3. It goes up as high as 3. And then if you look down here, right, so the minimum happens at this little sort of dip in this function, and that's at about -1. So y min equals -1. So to get the amplitude, I'm going to take the y max, which was 3, minus the y min, which is -1, and divide by 2. So we have to be careful with negative numbers. If you subtract the negative and the minus cancel each other. So we get 4/2. Which gives us an amplitude of 2. So what does that mean in practical terms? Well, again, if we had the midline, which is exactly halfway between the maximum and minimum value, that would be here. Okay, this is the midline. The amplitude is how far you'd have to go in either direction to reach a maximum or a minimum. So from the midline, you'd either have to go up to or down to reach an extrema. So it's how far you vary from the midline. Okay, now for the period, we're interested in how long it takes to repeat. So again, I'm just going to highlight this one repetition. You can pick any of them to do this calculation. Doesn't matter. But what we're looking for is how far it spans on the independent axis. So notice here that this is -1, -2. So this value is -3, where my drawing starts. And then I go until here, which is where it starts repeating. And this value, right, is 1, 2. So the span is from -3 to +2. So to go from -3 to +2, that is 5 units. So the period is 5. So how long it takes until we start repeating. So that's how we're going to find the amplitude and period for a function. So we're going to try this on the other 2 periodic functions we looked at. We want to try to approximate the amplitude and the period. It doesn't have to be perfect. So like this one wasn't quite at -1, but we called it -1. That's pretty close. I would say when you're approximating, don't go to more than like halves, like 1, 1.5, 2, 2.5 to try to approximate where something is. Okay, so here's the other 2 pictures. What I'd like to do is I'd like to give you 2.5 minutes to try to come up with the amplitude and period for these 2 functions. A couple quick notes here. So you see we're counting by 2s on the x and y axis for the first function. And then for the second function, on the up and down axis, this is -5 and this is +5, and this is the 0 line. And then across we have 10, 11, 12, 13, 14. Okay, so I'd like you to take 2.5 minutes, try it out, see if you can find the amplitude and period for these 2 periodic functions, and then we will go through them together. Okay, take about 30 more seconds. Okay, so let's take a look at these. So we'll start with the one on top. So again, to find the amplitude, we need to approximate the maximum and minimum y values. So eyeballing this, to me, 3 looks like it's about here. So I'm going to say that y max is 2.5, right? So roughly around there. And then similarly down here, I'm going to put -1 right about here. So I'm going to call y min negative 0.5. Okay, so hopefully you're in that range, right? Somewhere between 0 and negative 1. So to calculate the amplitude, we're going to do 2.5 minus negative 0.5 divided by 2. So again, be careful with the negatives. So this is 3 over 2, which gives me an amplitude of approximately 1.5. Okay, now for the period, I need to pick a point and then figure out when I get back to that point. You can do this anywhere on the graph. I'm going to start just at the top of one of the tall peaks. I just think that will be easiest. And so I'm going to trace this graph till I get back to that point, and I see that I will start the pattern again. So here, this goes from x equals 0 to x equals 6. So the span is 6 units in the horizontal direction. So my period is approximately 6. Okay. And again, you could have started, you know, top of a little peak to top of a little peak, but you should still get 6. Okay. So now let's take a look at our second function here. So again, we're approximating. So if your approximations are not exactly the same as mine, that's okay, but they should be relatively close, right? So here I'm looking for this maximum value, which I can see is between 0 and 5, but much closer to 5. So I'm going to call this my y max. I'm going to say that that is 4. Okay. And then down here, right, I can see that this y min, again, right, is between 0 and negative 5, but much closer to negative 5. So I'm going to call y min negative 4. Okay, so if you said negative 4.5, negative 4, somewhere in that range, that's pretty good, right? That's what we're looking for. So for the amplitude, we're going to say, okay, we're going to take our max minus our min and divide by 2, right? So again, careful with the negatives. We have 8 over 2, which gives me an amplitude of 4. Okay, so now I want to figure out the period. So I'm going to trace my graph until it starts to repeat. And you can eyeball this. You don't have to trace it. I'm just trying to give you a visual of what I'm looking at here. So it starts to repeat around here. So again, this is 10. And then this looks like it's right about 11.5, right? It's right between 11 and 12. So from 10 to 11.5, that's 1.5 units. So the period here is going to be 1.5. Hope you guys are okay in there. And so this is actually in years. I don't think you can see the units, but it does say in years. If you could see the units, then we would call it 1.5 years. Okay. So here we've approximated the period. We've done the amplitude. And so these are the things that we are interested in general for periodic functions, but we're going to sort of drill down and say, well, which periodic functions are we interested in for this class? And so what we're going to do is we're going to talk about 2 periodic functions that happen to model a lot of things in nature and biology that we will be using the majority of the time. We will have a couple that are not the ones we're going to look at next, but I would say 90% of the time, what we're going to be looking at is sine and cosine. Okay. So we're going to quickly go over some of the properties of sine and cosine and talk about what the period and amplitude are for sine and cosine as sort of a refresher if it's been a while since you took pre-calc. But in general, one of the main things that is going to be important for this class is if you do any calculations on your calculator for sine or cosine, you need to make sure your calculator is in radians. So we are studying everything in function form. We're not doing any geometry. So everything should be in radians and not degrees. Okay, so we're going to talk about sine first. So sine has the property that it's going to vary between 1 and negative 1. So when you draw a sine function, it goes up to 1 and down to negative 1. And so the maximum value for any sine function is 1, and the minimum value is going to be -1. Okay, and that's helpful for us because we know we need that maximum and minimum to talk about the amplitude. So the amplitude for sine x is 1 minus -1 divided by 2. So 1 minus -1 is 2. So the amplitude for any sine function is going to be 1. Okay, so if you have sine x or sine t, right, with nothing else done to it, you know that we vary by 1 from the midline up or down to reach the maximum or minimum. Okay, now the period for a sine function, notice that if we start here and we trace this function until we repeat, we end up a little bit after 6. Okay, anytime you're working with sine or cosine and you're a little bit after 6, that is most likely going to be 2 pi. If you're a little bit after 3, right, that's going to be pi. But if you're a little bit after 6, that's going to be 2 pi. So the period of a sine function, sine x, sine t, is going to be 2 pi. So every 2 pi units, the sine function is going to repeat. Now, I also want to point out that for a sort of general sine function, we are at 0, 0, and we are increasing to start, right? So sine goes up when we start, and sine starts at the midline. Okay, so this is the midline, it's right at the axis. And so we're not at a maximum or a minimum, we're right in the middle, and we start off increasing. Okay, and the reason I say this is because we're going to be looking at functions later and trying to determine, is it sine, is it cosine, is it negative sine, is it negative cosine? And so sine starts at a midline at 0. Okay, and if it's increasing, then we're going to have positive sine. If it's decreasing, that means we have negative sine because it got rotated. Okay, so we know the amplitude is 1, we know the period is 2 pi, sine starts at the midline at 0, and it starts off increasing. So these are all the properties that we want to try to sort of keep in mind when we're going through some of the problems. Now let's look at cosine. Cosine is very similar. Okay, so again, cosine is going to live between 1 and -1, right? So our cosine is going to vary between 1 and 1 and keep repeating forever and ever. So the maximum value is 1, the minimum value is -1. So again, the amplitude will be 1, just like with sine. So here, if you're at the midline, you can go up 1 unit or down 1 unit to get to the extrema. Similarly, if we're talking about the period, if you trace the graph until it repeats, again, we're a little bit past 6. And so just like sine, we know the period is 2 pi. Okay, so if you have cosine of x or t or whatever the variable may be, the amplitude will be 1 and the period will be 2 pi. So let's talk about the properties of cosine that help us identify it. So notice that at 0, so when x equals 0, cosine is at a maximum. Okay, so if you look at this picture, we start at the top of the hill. So if cosine is at a maximum or a minimum, when you are looking at what's happening at 0, if it's at a maximum, you just have cosine x. If your graph starts at a minimum, then you have negative cosine of x. It's been rotated. Okay, and this will all make sense when we're looking at graphs in a little bit. So what we want to do is we want to start thinking about what sorts of things we can do to sine and cosine that's going to change the way they look, right? So we still have some version of sine or cosine, but what are some of the common things we do to graphs to change what they're going to look like? Okay, so that's what we're going to talk about first, and then we're going to talk about how we use sine and cosine as a model. Okay, so in terms of how things look, we're going to take a look at 2 different examples here. So in both of these pictures, this is just a graph of sine right? It comes up to 1, down to -1, has a period of 2 pi. These are both sine pictures. And what we want to do is we want to say, okay, how does this picture change if we change our function to be 6 sine, right? So instead of just sine x, if we have 6 sine x, what does that do to this picture? Okay, and so for the second one, we're asking the question, if we have 3 sine x minus 2, what does it do to the picture? How does it change? Okay, so you may remember from graph shifting, if you watch some of those videos, you may remember from algebra, but if you don't remember what the impact of these things are, I would like you to try to figure it out. So you can use a calculator to graph it and see what it looks like. You can try plugging in some values to see how that will change. Whatever you need to do to try to visualize what you think might happen. So I want you to try these two. I'm going to give you 3 minutes to try to think about how the new graph will look when we impose these functions on sine. But try it out. Feel free to check in with someone next to you, and we'll go through it together, like I said, in about 3 minutes. See what you can figure out. Okay, take about 30 more seconds. All right. So for this first one, we have 6 sine x. So we're trying to figure out what impact this 6 has on our graph of our function, what that's going to do. So I want to remind you that the 6 is multiplying sine x. So whatever the y values were for sine x, they are now getting multiplied by 6. So they're going to be 6 times bigger in the y direction, right? It's going to impact that dependent output. So the easiest way to start these is to start with the zeros, right? Because if it's 0, then 6 times 0 is still going to be 0. So any place that the y value was 0, still going to be 0. Okay. Now we know for sine that it's got a maximum of 1 and a minimum of -1. So if we multiply those maxes and mins by 6, that means now instead of having a maximum of 1, we need to go all the way up to 6. And instead of having a minimum of -1, we have to go all the way down to -6. right? And so that's going to be something similar over here. And then again up here. So that helps us see that what we're doing is we're stretching our function here by a factor of 6. Okay, and something important I want to note is it doesn't impact the horizontal direction. We still have a period of 2 pi, right? The whole thing completes its cycle in the same amount of time, but the y values have been pulled by a factor of 6. So when you multiply something, it takes every single y value and multiplies it by 6. It goes up 6 times as high, okay? Now, for the second one, we're going to have 3 sine x minus 2. And so the 3 is going to have a similar impact that the 6 did. So I'm going to do this in 2 steps. I'm going to do 3 sine x first to see what the 3 does. And then we'll ask, what does the minus 2 do? So again, the zeros stay 0, right? Because 3 times 0 is still 0. But now instead of going up to a maximum of 1, we have to go up to a maximum of 3. And instead of a minimum of -1, we have a minimum of -3, right? So here we're stretching by a factor of 3. Okay, so this is y equals 3 sine x. So if we were just multiplying by 3, we would just stretch everything in the vertical direction by 3 units. But we also have this minus 2. So that means we need to take every single value and shift everything down by 2 units. When you add or subtract a number at the end, it vertically moves it. If you add it, it moves it up. If you subtract it, it moves it down. So that means instead of 0 as a dependent value, we need to move this down to -2. Instead of 3, we move it down to 1, right? So on and so forth. We move everything down by 2 units. So the picture looks the same, but it's shifted down. So we get something that looks like this. So y equals 3 sine x minus 2. So we've moved everything down by 2 units. Okay. So when you add or subtract something, it moves it up and down. Okay. So let's try one more. We have one more graph situation. Okay. And so here again, this is the original sine graph. And the question is, what happens when you have sine of x plus pi over 2? So notice that the addition of pi over 2 is inside the argument. That is different than when we subtracted 2 outside of the argument. When it's inside the argument, something different happens. It's not an up and down shift. So I want you to take, I don't know, a minute and a half. See if you can figure out what impact that pi over 2 will have. You can just graph it on your calculator, try a couple values, try to think it through, make an educated guess, and then in about a minute and a half, we'll go through it together. Okay, take about 30 more seconds. Okay, so if we have something inside the argument that is added or subtracted, it is going to shift the function, but when it's inside, it shifts it left and right. And this one to me is a little counterintuitive, but when you add something on the inside, it's going to shift it left by that amount, which means we're going to take this whole graph and move it pi over 2 to the left. So pi over 2 on this picture is right about here, okay? Which means that we are moving this point to the origin, okay? And so when we move everything to the left by pi over 2, we still are following what that graph was doing at that time. So every point gets moved over. So when we do that, we get something that looks like we're going to come down here. We're going to come back up here. Okay, so we get something that looks roughly like this. And so that is the same as this picture here. Okay, but moved over to the left by pi over 2. So I did that in green and red. So if you're colorblind, that might not stand out, but this particular line got moved over by pi over 2. So when you have something on the inside, it moves left and right. If it's added, it moves left. If it's subtracted, it moves right. Okay, so those are sort of the common things we do to any graph, really, to transform graphs. But that's what it looks like on sine and cosine. And the reason we want to talk about that is because when we model periodic functions using sine and cosine, we use a model that's called the general form, okay? And the general form for the sine and cosine models look like this. So y equals a sine bt plus c, y equals a cosine bt plus c. So you can see that we're doing things to these graphs, right? We're multiplying by something, we're adding something. And so what we want to do is we want to make sure we understand the impact of what these actions are, right? By practicing up here with these types of graphs, but then also linking it to what we're talking about in terms of amplitude and period, right? So that sort of brings it all together. So how is amplitude and period related to what we're looking at in this general form? Okay, well, I want to remind you that for a general sine or cosine graph, right, the amplitude was 1. So it lived between 1 and -1, and it varied by 1. So if we were to multiply sine or cosine by some number a, that would become the new amplitude, okay? Because that 1 would get multiplied by that number, and the -1 would get multiplied by that number, and that's how much it would vary. So just like with that 6 sine x, the amplitude became 6 because now we were living between 6 and -6, so we varied by 6. So if we have a function in the general form, the amplitude is the absolute value of a, okay? And so I want to take a minute to talk about how we're going to use the general form, because there's 2 scenarios. The first scenario is that you are given the general form, so something like 5 sine of 3t plus 7, right? So a, b, and c are all numbers. You are given the general form, and then you are asked questions about it, like what is the amplitude, right? And then you'd say, okay, the absolute value of whatever a is. So that's one direction. Another direction is that you are asked to find the general form from some set of information, whether it's a graph or a table or a word problem. You have some information and you are trying to find the general form. Now, when you go in that direction, I want to point out that if you know the amplitude from our formula, right, we took the maximum minus the minimum divided by 2, you've somehow calculated the amplitude, you still need to consider if a is positive or negative. So if your amplitude is 5 from your calculation, in the general form, a could be 5 or -5, depending on what you're modeling. And so you have to do the work to figure out, is it positive or negative? And we're going to be practicing this in a few minutes, so you'll see what I mean, okay? Now for the period, remember the period is how often we repeat. And so the period is 2 pi over b, okay? So how do we use the period? Well, if we have the general form, right? If we are given the formula, we can find the period or how often it repeats by taking the b value and plugging it in. If we are trying to find the general form from a picture or something like that, then we would need to set the period equal. So we would look at the picture and say, oh, it repeats every 10 units. We'd set 10 equal to 2 pi over b and solve for b, and then we could plug b in. Okay, so it depends on which direction you're going. And then finally, there is the vertical shift, this plus c. Was our function moved up or down? Okay, and so if you have the function given the general form, you can read the c off by just looking at what was added or subtracted. But if you are trying to find the plus c, there's a secondary formula we can use, which is y max plus y min divided by 2. So remember, amplitude is y max minus y min divided by 2, but the shift is y max plus y min divided by 2. Okay, so what we're going to do is we're going to practice looking at graphs and trying to figure out, right, how do we get the general form from this graph? And so when we do this, there's certain steps that we need to take to make sure we have all the pieces. And you don't need to do these in any particular order, but the things that you need to do the amplitude, right, by doing the maximum minus the minimum divided by 2, just like we were doing at the beginning of class. You need to find the period, like we were looking at the beginning of class. How long does it take to repeat? And then you need to use that, find b. We need to look at, is the function sine or cosine? Okay, so we need to figure out, again, the way that I always look at it is it at a maximum or a minimum at 0? If it is, then we're talking about a form of cosine, either positive or negative. If it's the midline, then we're talking about sine. And then we also need the vertical shift. Okay, so these are the 4 things that we are trying to determine from the picture to put it all together to find the general form for the model. Okay, so we're going to practice this, but I do want to give you a disclaimer, like this is not trivial, right? This is kind of hard when you first start doing it, but once you've done it enough times, it becomes a lot easier. So like if you can do this solidly for like 5 or 6 examples, then you'll be able to do them pretty straightforward. But the first couple times it feels clunky and weird, okay? But let's try it. Let's get through it. We'll see how it all works. So we're going to look at 2 functions here, and we're going to try to find a possible formula for each of the following functions based on their graphs. So these are the 2 pictures, okay? So I want you to notice that on the y-axis, we're counting by 2s, 2, 4, 6, 8, 2, 4, 6, 8. And then on the x-axis, we're counting by 1s, 1, 2, 3, 4, 5, 6 on both these graphs, okay? So I'm gonna, let me fold this over. The things that we're trying to find for both of these. Here was our list of the things we need to put together our formula. And so when you try to do this, the other thing I want to remind you is that if you have a value a little after 3, that's probably pi, and a little after 6 is going to be 2 pi when you're considering what's going on, okay? So I'm going to give you about 3.5 minutes to try to find the general formula for these 2 functions. If you can't find the whole formula, it's okay. If you can find some of these pieces, that's great. So maybe you can find the amplitude and the shift, or maybe you figure out if it's sine or cosine, right? But try your best to see what you can figure out from these and see what you can put together. And then we'll go through it together in about 3 minutes, okay? Okay, take about 30 more seconds. Okay. So as I mentioned before, you don't have to do these in any particular order. These are just the pieces you need. So if you're more comfortable, calculating some things than others, you can certainly start with whatever you're most comfortable with. It doesn't really matter what order. We just need all 4 pieces. So I'm going to start by finding the amplitude and the shift. And the reason I'm starting with these 2 is because they use the same values. So I'm just going to calculate those and see what they are, and then I'll bring in the other 2 things we need. Okay, so for the amplitude and the shift, we need the maximum and minimum values here. So the maximum value, if I'm looking here, my y max looks like it's just about 3, and my y min looks like it's going to be -3. So for the amplitude, I'm going to do 3 minus -3 divided by 2. Okay, be careful with the negatives. And that's going to give me an amplitude of 3. And for my shift, I'm going to do 3 plus -3 divided by 2. 3 plus -3 is 0. 0 divided by 2 is 0. So I have these 2 values now, and I know that they're going to come into my formula. So the next thing that I like to do, so this is how I usually start it, but again, you can do this in any order you want. But at this point is when I typically try to determine, is it sine or is it cosine? Okay, and so there's many ways to do this. And so whatever you're most comfortable with is fine. I'm just going to tell you how I figure it out. So again, I like to go to where x equals 0 and see, is it at a maximum or minimum? If it's at a maximum or minimum, I'm thinking cosine. If it's at the midline, then I'm thinking sine. So here I notice it's not at a maximum or minimum, so I'm thinking sine. So once I'm thinking sine, if I'm increasing, I have positive sign. But if I'm decreasing, like I am here, that points me to negative sine x. Okay, so I have some form of negative sign because I'm starting at the midline and I'm decreasing. So now I think about how I'm going to start to put my model together. So I have a negative from the negative sign, but I have an A, which is my amplitude. So -3 sine. I haven't done the period yet, so I'm not going to put anything in the parentheses quite yet. But then I know my shift is 0, so I don't have plus anything at the end. If I did have a shift, I'd throw it on right here. So now, my last part, I need to figure out the period. So what I want to do is I want to look at how long it takes to repeat and set that equal to 2 pi over b. So I look at my graph here, and I see I start to repeat a little after 6. And we talked about how a little after 6 is likely going to be 2 pi. So I set 2 pi equal to 2 pi over b. So I see here that b is going to be 1, right? Because anything divided by 1 is itself. So if my b is 1, that means I have a 1 up here in the argument. Typically, we don't write a 1, right? We usually just leave it as whatever the variable is, but it's up to you. So I need to make sure I use the right variable. You probably can't see this, so if you didn't use x, that's fine. But there is an x on the graph. So this is going to be 1x. If this was a t, you'd put in a t, right? If it's a q, you'd put in a q. But ultimately, my model here is y equals -3 sine x, or -3 sine 1x, which means the same thing. Okay, so that's how I'm starting to put all this stuff together. Again, if you didn't get the final answer, that's okay. This is our first time. But if you got some of the pieces, then that's a step in the right direction. Let's look at the next one. So we're going to do something similar here. Again, you can do the pieces that we need in any order. I'm just going to do them in the order that makes sense to me. So I'm going to start with my amplitude and my shift. Okay, so I'm going to need the maximum and minimum y values here. So it looks like my y max is 3. And it looks like my y min is going to be 1. Okay, so for the amplitude, I'm doing 3 minus 1 divided by 2, which gives me an amplitude of 1. And for my shift, I'm doing 3 plus 1 divided by 2, which gives me 2. Okay. So once I have my amplitude and shift, that's typically when I try to figure out, am I dealing in sine or cosine? So I go to 0, I go up to the graph, and I notice that I'm at a maximum, right? I'm right at the top of one of these hills. So when I'm at a maximum here, that tells me I'm dealing in positive cosine. If I was at a minimum, it would be negative cosine. So I start to put together my model. So y equals 1 cosine. I haven't done the period yet, but I know at the end, I'm going to have a +2 from the shift. Okay, so the last thing that I do here is I consider my period. So again, I want to know when it repeats. So I start at 0 and I go until I get back to the maximum. It's a little bit after 6. So the period is 2 pi. I set that equal to 2 pi over b. Again, my b is going to be 1 here, right, to make those equal. So I have 1x. So I have one cosine of 1x plus 2. And again, we don't usually write the ones, so we could also write this as cosine x plus 2. Okay, so again, hopefully you got some of the pieces, right? So maybe you got the amplitude, maybe you got the period, maybe you figured out it's cosine, right? And now we're starting to put it together. So we're going to try one more now that we've gone through two pretty carefully, and hopefully you will be able to get the general equation for this particular function. Okay, so again, we're counting by 2 on the y-axis, and we're counting by 1 across this way. Okay, so I'm going to give you 2 minutes. Try your best to come up with the general equation for this one. See what you can figure out, and then we'll go through it together. And as always, feel free to talk to someone near you if you think that that would be helpful. Okay, take about 30 more seconds. Okay. So hopefully now that we've done 2, this one, went okay. So let's see what we can come up with here. So starting with the amplitude and the vertical shift. Let's see what we can come up with for our y max and our y min values. So it looks like here that our y max is going to be 4. And our y min is going to be -4. So for our amplitude, we have 4 minus -4 divided by 2, which is 8/2, which gives me an amplitude of 4. And then for our shift, we're going to do 4 plus -4 divided by 2, which is 0 divided by 2. 0 divided by anything that's not 0 is just 0. So we have a good start on this. And now we need to consider, is this sine or cosine? So at x equals 0, this is at a minimum. Okay, so if it's at a maximum or a minimum, we have some version of cosine. And since it's at a minimum, that tells me I have some version of negative cosine. Okay, so a maximum is positive cosine, a minimum is negative cosine. So when I start putting this together, I put my negative out front, then my amplitude value, and then my cosine. I haven't done the period yet. And then we said that the shift was 0, so I don't need to put anything there. So for my period here, I look at when I repeat. So I look at the picture and I see that this is different than the last couple, but I see it repeats a little after 3. And so I believe that the period is going to be pi, because if we're a little bit to the right of 3, we're talking about pi. So I set that equal to 2 pi over b. So I can multiply the b up and bring the pi down. So b equals 2 pi over pi. The pi's are going to cancel. And I get b equals 2. So up here, I have 2x. And again, there was no shift, so I leave that without anything at the end. You can write plus 0 if you really want to, but you don't have to. So I get -4 cosine of 2x. Okay, so hopefully you were able to figure all those pieces out and put them together. But if not, again, once you've done a handful of these, they do get easier. Okay, so now let's look at this word problem. Okay, so similar idea. We want to find the general form to represent what's happening here. And so the problem says, Boston averages 15 hours of daylight in June, 9.5 in December, and 12 in both March and September. Assuming that the number of hours of daylight varies periodically over a period of 1 year, write the expression for n, the number of hours of daylight, as a function of t. Let t be in months, and t equals 0 corresponds to the month of June. Okay, so when you see that you're representing something periodically, that's when you know you're looking for a general form in either sine or cosine. So we need to figure out how to take all of this information and come up with a general form, much like we did when we had a graph. Okay, so the information is just in a different form. Now, typically, when you have a word problem like this, you're not going to be given a graph, but I did provide an axis here, so if you printed it out, to sort of sketch what's happening, because sometimes it's easier to figure out what's going on if you draw it, but you don't need to solve this problem. Okay, so I want you to take about 2-3 minutes and see if you can come up with the general formula. So again, think about what kind of information do we need for the amplitude and the shift? Do we have that information? What kind of information do we need to figure out if it's sine or cosine? Do we have that information? How do we represent the period? And we want to be really careful here and make sure that we're using the right variables. So in your final answer, you should have an n and a t, because those are the variables that were given to us to use here. Okay, so take about 3 minutes, see what you can figure out, see what you come up with. Go ahead and graph it if that's helpful, but you don't have to. And then we'll go through it together. Okay, take about 30 more seconds. Okay, so let's go through this. As I mentioned, you definitely don't have to graph this, but I am somebody who likes to draw pictures of word problems. It helps me understand what's happening. And so I do this often as a strategy. So I'm going to use the picture, but you definitely don't need to. So here I want to start with sort of the end. Let t be in months, and t equals 0 corresponds to the month of June. Okay, so when I'm starting here, that means at 0 right here, this is June, right? July, August, September, October, November, December, January, February, March, April, May, June again, right? So this is how I would notate it, just so I remembered what months we were talking about where. So t equals 0 is June, and I know that in June, I get 15 average hours of daylight. So that's what's coming up here, daylight. Okay, so at time equals 0, I'm going to go up to 15. So I know it's got to be 15 here. And then again, 12 months later, right, 15, 15. Okay, so that's the first piece of information. I also know that in December, it's 9.5. So if I go to December, I can plot a point right about 9.5. Right, it doesn't have to be perfect, but you know, here, right between 9 and 10. And then 12 hours in both March and September. Okay, so September, I come up to 12, so roughly here, and then also in March, here. Now, because it's periodic and because it repeats every year, I'm pretty confident that the shape of the graph follows these dots, right? I can't have like lots in between because the period is, you know, the full year. So I can't have lots of periods in between. So this helps me understand the information where I now know that my Y max is 15, my Y min is going to be the 9.5, right? My period is going to be 12 months, right? Because time is in months. And then the picture helps me understand whether it's sine or cosine. So what I notice here is that I'm starting at the maximum and then I'm coming down. So if I start at a max, I'm thinking cosine. Okay. So now I can start to put these things together using the formulas that I have. So my amplitude, I know it's going to be my max minus my min divided by 2. So that's going to give me 2.75. My shift is going to be my max plus my min divided by 2. And that's going to give me 12.25. Okay. And so I know it's cosine. So let me start putting this all together. So again, I'm not going to use y because it asked me to use an expression for n. So I have n equals, now my amplitude, so 2.75. I said this is cosine. I haven't done the period yet, plus 12.25. So the last piece I need to figure out is the period. The period is 12 months, right, which is the full year. So here the period is 12 in this scenario. And so I need to set that equal to 2 pi over b. So I can multiply the b up and divide the 12 down. So I get b equals 2 pi over 12. I can simplify that a little bit into pi over 6, right? The 2 and the 12 simplify. But I'm going to leave pi as pi. I'm not going to turn it into a 3.14. We want it to be exact. And so that is my b. So when I go back to my formula, I get pi over 6, and my independent variable here was t. So I get pi over 6 times t. So this is what my equation looks like for this model. Again, you don't need the picture. I think the main thing the picture helps me with is figuring out if it's sine or cosine, but sometimes you can figure that out without a picture. I will mention, okay, because this has come up a few times via email, you have to enter this as pi over 6. You cannot turn this into a decimal. This is an exact answer, and if you put it into a decimal, it becomes an approximation, okay? So that's our last example for now. I would recommend that you read through the textbook chapter just to see an example of a table by the homework. But otherwise, that's the kind of stuff we're doing. And that's the end of chapter 1 for us. So if you have any questions, come by Drop in Help this week. Otherwise, have a great rest of your day.